everybody. It's Tuesday night? Wednesday night. Tuesday night. Tuesday night? Tuesday night. Sorry. It took a little while there. Every day is running into the other here, my friends. Welcome on in, everybody. Welcome. Surprise coding stream is a surprise. I've turned the webcam off for a little bit here because I'm standing. Because if I turn the webcam on, this is what you see. So you want to get the lower part of my face because I still haven't figured out how to properly mount the webcam so that it works when I'm standing and when I'm sitting. But my friends, welcome on in. So I am motivated. I guess is what's going on here. I was like, I kind of want to play a game, but at the same time, I just want to get some things done here. And I've been doing some coding off camera last couple days, and I've made some progress. And I want to show you what's going on. So we're in chapter 9 here still, but there have been some changes. Is this good? Did I break something here? What did I break here? Oh, I know what I did. Okay. Yeah, I'm trying to figure something out here, so that's what's going on. Okay. So I've managed to go through everything that was in chapter 9. And so if I run this right now, you'll see that I'm able to successfully load this Spanza model that the game, or that the chapter is using. The chapter actually uses, the book uses for pretty much the rest of the chapters. This is, by the way, just a little background on this. I believe this was originally made as a test for the Crytek engine. And it's just kind of free and it's out there for people to use to test their engines and stuff. So awesome stuff there. Now, I've run into, the only issue I've run into is one of processing the inputs. Now, you remember on our last stream, I spent most of the stream just kind of going through and being like, I kind of want to do the keyboard handler a little bit differently than the way they had it in the book, because I felt like the way they had it in the book wasn't, really taking advantage of Java and all that stuff. And I'm happy to say the keyboard handler is working. The mouse handler I still haven't quite gotten to work. It's being called, but it's not quite doing anything. And I think they both sort of suffer from the same root cause here. But let's kind of get into that first. First of all, before I jump too far into that, you'll recall that I kept wondering why, like when I was rendering that rotating cube, I kept wondering why my cube was so much smaller on screen than the one the book was rendering. And, it's hard to kind of debug that kind of thing because it's like, it could be any number of 1,000 variables, right, at work. You can kind of track it down, and I was trying to sort of track it down a little bit here and there. And I was like, whatever. Well, maybe it's not a big deal. Maybe it's just something that'll flesh itself out later. Well, when I got done this chapter 9's code, I went to render the model, it was crazy looking. Like every part of the model was like perspective foreshortened out the wazoo. Like it was all stretched way out. I was like, what is going on here? This is really weird. And I was kind of troubleshooting a few things. I was debugging a few things. I'm like, you know, these numbers look right. These numbers look right. Those numbers look right. And it turns out the root problem, the thing that was causing my cube to look weird and everything else was, and I'll pull it up here. So we have this class called projection, right? And it's got a field of view in it. Now the field of view is set for me. Where's it at? I believe it is set. Do I have a setter here? Here it is. So I was setting the field of view up here as a static, and essentially I took that basically from, like, I was setting field of view just to 60. And I was taking that from the fact that they were loading up 60 from their properties file, and then they were just going forward with it. Well, what I didn't notice at first, and I noticed it later after I was really going through and coming through stuff, is that they weren't using 60 directly. They were doing a math to radians on it, right? Which makes sense because, you know, this is a perspective, so you kind of want, you know, some, you know, spherical circle coordinates kind of going on there. Once I popped this math to radians on it, everything worked fine. So it turns out that the whole problem I was having was that my field of view was just completely whacked out. It looked, it kind of looked a little bit like a cross between the Hall of Mirrors effect that you would get in Doom whenever you would use the cheat code to clip out of the level. It was kind of a little bit of that, and a little bit of the I'm trying to think of the name of the game, but there was a game where you would get a power up that would let you go like super speed. It was a first person game, and like the world would kind of, the perspective would like go way out. I think there was maybe it was a setting in one of the games where you could just, I think it was Minecraft even maybe, where you could toggle the field of view like way out to maximum, and it looked just crazy. Well, that's what I was getting a combination between those two things. Yeah, so that's what I was missing. So finally figured that out. I mean, this is the kind of thing that would drive you insane, right? Because you're just like, there's any number of variables that could be coming into play, and then it's just like, oh, it's just that. That's all it was. So that's why, you know, when I run it now, in fact, you know what? I'll show you what it was looking like, because I can show you that this actually makes all the difference here. So if I just set this to what I had before, this is what I was seeing. Yeah. So I loaded that up as like, oh no, am I not loading the model correctly? Like, what's going on here? And then I kind of realized, like, everything's sort of stretched out. What's happening there? And so yeah, go back and put this back in, save that, and now everything's correct. So there's that. There's another thing though that's going kind of wrong here. Kind of wrong and kind of right. And this is sort of the conundrum that I'm facing here a little bit. So I was talking about the keyboard handler and key press and all that stuff, and how I'm doing it a little bit differently than the book's code was doing it. And I had to make a little change to, where did I make that change? I think I made it here. Yeah, I had to make a little change to the keyboard callback handler, because one of the things I was seeing was that I was debugging it and I wasn't seeing the keys pressed being set in certain cases. And I realized that there might be some kind of like race condition going with threads and stuff. Whether or not that was true or not is neither here nor there. But what I did was I wrapped it in as a synchronized set. So now every time I put something in keys pressed, it'll be synchronized, or I remove something from it, it's synchronized. Which, you know, you pay a little performance penalty for it, but it's probably worth it, because now you know every thread's going to see exactly what you wanted to see, especially given that it's a static. And that helped tremendously. Like, I was starting to see actually key presses come through and everything else. However, here's the problem. And I'll see if I can kind of show you what's going on. If I go to, I guess is it Vulkan? It was Vulkan Engine, wasn't it? Yeah, I think it's Vulkan Engine. Yeah, so I register my keyboard callbacks, and I was trying a couple different ways of doing it. Like, I was doing this, which I don't think is actually necessary, but I wanted to make sure this wasn't what I need to do, and I've verified with the key handler that I don't need to do that, so I'll probably pull those out of there. But I'm setting the key callback to my key handler, and I'm registering the camera input callback class in there and everything else. So that's all good. When I come up to here, so this is our main game loop that's going on here. Now, in the book's code, they've got, this is their main game loop. They've got poll events here, which calls input on this, which just does the GLFW poll events, and then input on this, which grabs delta positions of the mouse cursor and everything else. So we're still relatively the same there. But then they do, after they do that, they do this game logic input, and they pass this sort of delta time in. Now, this delta time this is what I was struggling with last week, or on Sunday, or Saturday, I mean, where they like set it to now at the top of the loop, and then they do initial time, which is set outside the loop, and then they reset initial time to now. And I'm like, this, you know, it kind of makes sense. It kind of doesn't, because it's like, you know, it's a pretty tight loop. And so I go look at their input here. We'll look at their implementation. And in their inputs, this is where they're doing all their checks for key presses and for mouse inputs and all that stuff. Most importantly here, they've got this move variable, and that takes the difference of time in milliseconds and multiplies it by 1%, basically. It takes 1% of it, 0.01, yeah, times that and does its thing. And what that's doing in the book code is it's making it so that, like, when I run this, and this is the book code running, as I move around, I move fairly smoothly. You know, it might be like a tiny stutter here or there, but it's, for the most part, it's very, very smooth. And I like that. I like the smooth moving camera. I think that's fantastic. Now you'll see I added a debug log message there to see what was coming out, and you can see they're doing relatively, hey Outlaw, welcome on in. You can see that their code is doing relatively between 16 and 18 milliseconds. And it's moving the camera by 0.17, 0.16, blah, 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 blah. There's a little 0.14 there. So it's relatively stable. There's a few little stutters, you know, where it goes a little bit faster than it did otherwise. But so by going faster, it actually ends up going slower. It makes sense, trust me. So yeah, everything was very smooth. And this is the book code running. So here's the thing. They're pretty consistently getting like 16, 17 milliseconds through this, doing all these checks and everything else and coming out the other end. I, on the other hand, have accidentally broken that pattern because the way I've written the code, it goes too fast. In other words, my code is too performant. Their code is too slow, and my code is too performant. What do I mean by that? It takes this code that they've written between 15 and 17 milliseconds to complete. And so this diff time milliseconds is always like somewhere between 15 and 17 milliseconds when it comes back around the next loop. Mine, on the other hand, I come into poll events. You can see in here, I just do GLFW poll events, right? Like they did. And in here, I just do the cursor deltas. And I added this in here to do the callbacks, but I might move that, once I try to look. I know the mouse isn't working right now, but I might move that around just to try to get the mouse working and stuff. So I do that. And then there's nothing in game logic. It just comes around, it renders, it then I've pushed a timer out to this input timer thing, but it's basically doing the same thing that the other one was. And it comes back around and then it pulls events again. The problem is I was consistently getting 0 milliseconds. Between 0 and 1 millisecond. Because I wrote the code so well that it's literally 17x faster than the and that might even be more than that, but like 17x faster than the book's code. And what that means is my camera, every time it comes in to do the check for how far we should move, it's constantly getting 0. It's 0 times the diff time millisecond is 0 times the movement speed, which is 0. And so the camera doesn't move, except every so often it takes 1 millisecond and it moves just slightly. So my conundrum is, I want this camera to move as smoothly as the camera that they had, but I wrote my code too damn well. So either I write my code worse, which I'm not loving the idea of, or I have to figure out a different way of doing this. So what I've been working on is, I created a, as you probably saw here, where did I put that at? So I created this input timer class. And instead of doing system get current time milliseconds, I'm doing nanotime. So I'm doing nanoseconds. Now the nanoseconds are kind of all over the place, which I would expect because they're nanoseconds, not milliseconds, right? So when I run this and I actually do some keyboard input, you'll see, actually it kind of disappeared. That's new. Hang on. What happened there? Did I mess something else up? Oh, I think it went super duper fast. Let me, I need to, where did I put that, thing at? Movement speed. Let me, clamp this to 0.17f, which is about the fastest that their camera would go. So this shouldn't give me anything faster than 0.17, hopefully. We'll see how that goes. So we come back in here again, and you can see it's herky-jerky. It's not so smooth, which is a bit unfortunate. There's also, for some reason, a stutter where, like, if I switch directions, it's sometimes not processing it. So I don't know. I think I'm still getting some 0 some things translating to 0 here. So if I go and look at my log where I'm printing out the movement amounts, come down here, yeah, you can see like just using nanoseconds. Remember, this is 4,689 nanoseconds it took to run my code. 3947 here. So we're only moving by 0.02, 0.05, 0.12, we got a little speed there. 0.0, because it's not going to go, I mean, you know, it's going to try to do all this, but, you know, let's just clamp it to here for a second. All right. And it's just kind of all over the place. So I can probably work with this. I mean, hell, this one gave us 4-point scientific notation. Like, e to the -8 is 10 to the -8. So that was 0.0, like 8 zeros and then that 4. Or 7 zeros and then that 4. Like, it's just insanity, some of these numbers I'm getting. Right, so it's barely moving, and sometimes it's jumping a little bit, and sometimes it's not doing even that. So yeah, it's kind of all over the place. I have only myself to blame for being so damn good at my job. Humble brag. So yeah. So now I'm kind of stuck with how do I make this work? Do I add a delay in and go back to milliseconds and just delay for like 16 milliseconds? Do I try to fudge it somehow? That's kind of where I'm at. And plus I got to get the camera stuff. I got to get the mouse to move correctly, because the mouse is not responding when I'm in game. So although it is getting called, I do see like log messages of it getting called. It's not saying that it's handling anything though. So that's the tricky part. So yeah. What I'm trying to figure out is, do I put some, like, I mean, we'll be doing a space game, so a lot of things are going to be around velocity and stuff like that. But even in a regular game, even in like a first-person shooter game or whatever, in order to get more natural character movement, like your character, you may not notice it too much, but your character does sort of ramp up in speed. They don't immediately go from 0 to 20 miles an hour. There's a ramp up time. Now, depending on the game, that could be a very short ramp up time. It could be a slightly longer ramp up time, but there's always something there. My goal is to have like some kind of ramp up time to a maximum speed. And then when you let go, as you're holding on to the key, and then when you let go of the key, I want it to go instantly back down to 0. Because if I don't instantly go back down to 0, your character will start moving a little bit further, and we get into the, like, there's games that do that where you, like, there's a ramp down speed, and you know it becomes a lot harder to sort of manage your character on like a platform or something like that. I don't want that. I just want it to like instantly stop when you stop. And I think the instant stop thing is probably easy enough. It's the ramp up that I'm trying to figure out what I do there. Now, my thought is to possibly base this input timer on the milliseconds, and then have it over a certain number of milliseconds reach its maximum potential. So like basically I would say take the maximum speed and divide it by the delta, or divide it by a millisecond timer that's going up every time it comes in, more or less, and then that'll give you like a percentage until you eventually hit 100%, and I would just clamp it at 100% then. That seems like something. It's the logistics of that I'm kind of struggling with in my head right now. It's like, how do I make that happen, and not lose my damn mind in the process? Right? Because right now I've got input timer as a singleton, and I think it probably should stay a singleton. Probably should stay a singleton. The thing is though, and I can have like a counter. I can just keep doing system current time milliseconds every time I come into the delta logic here. So this would be, instead of nano time, it'd be current time milliseconds minus the last one, and then set minus the last one, and then I'd have some kind of method here that like tick here, which would then set it to a new value, the checkpoint to new value. So that would allow me to reset it when you let go of the input. The thing is there's many different types of input, right? Like right now we're just doing keyboard and mouse, but there could be joystick input too. And all of those I'm thinking are probably going to need their own timer, because if you were running at maximum speed and then you whipped your head around with your mouse, you wouldn't want it to go at like maximum speed, right? There would probably still be some kind of ramp up, and potentially the ramp up would be different for the mouse versus the keyboard, depending on like maybe a sensitivity bar or something like that. Same with the joystick. So, and also we got to like account for a dead zone, right? Like there should be a little bit of a dead zone with the mouse and a little bit of a dead zone with the joystick set. If you make a tiny bit of movement, you don't get like a stuttery movement. You know, you have to there has to be sort of intent behind your movement kind of thing. So that kind of necessitates those having their own sort of timers, for want of a better term, which means this is no longer a singleton. This would be just kind of a thing that we fire up, like we initialize before the game loop, and then I guess constantly take care of it at some point. I mean, we'd still have to get an instance of it. Is that true? Yeah, we'd still have to get. I guess there would be 3 classes, and they would be each static, or something. Each of them being singletons or something like that. I don't know. This is This is one of those instances where it's kind of sort of breaking my brain a little bit. Now, if I were to, let's just say, for shits and giggles here, if I come back here to where this move is, and I just set it to let's see, 0.17 is what we were getting. Let me just set it to 0.17 every time. And let's see what that does. I mean, I suspect it'll still be herky-jerky because it's not going to spin up to it, but let's just see where we're at with it. It's actually not terrible. What's weird though is that there's this little stutter, and I don't know what that is. It kind of stutters a little bit. When I first change direction, it kind of stutters a little bit. I don't know what, because I kind of want it to instantly, like I don't want this little delay here, and also sometimes the delay is pretty long too. So I think something else is going on there, but this actually isn't terrible if when I just clamp it to that, or when I just set it to that. So maybe I'm just, like it's actually kind of doing the same effect. So I wonder if maybe I'm overthinking it a little bit. I mean, that's entirely possible. So come all the way out here. This is the outside of it. All right. Yeah, maybe I'm overthinking it a little bit for now. Maybe we should just revisit it. Because it's kind of working the way that it's just this way is kind of working the way that the book code had it. So I think maybe let's just, you know what, let's just worry about the mouse then. I think the keyboard's handled for now. I'm gonna punt and just say that this is fine this way. So if I let's do the same thing in the mouse input handler. Well, actually, all that's coming through here, right? Yeah, all that's coming through here. Mouse move. So I think the only thing wrong with the mouse handler right now is handled is not ever true from what I could tell. So we gotta find out why our delta cursor position is not greater than 0. So let's see. What do I want to do? I don't want to do this. Let's do, so first of all, let's I'm gonna set this to trace so it doesn't keep spamming my log here. It's nice to have if I need it, but right now I need my log to be relatively clean so I can easily pick out what's going on. I'm going to delete the one that's there too, so it recreates it. I think first of all, let's see if it is ever true. So I'm going to put this up here. first. And let's see if I ever get any log entries. So I'm just moving the mouse around. Okay. That, by the way, if you're ever wondering why the mouse gets big like this, that's a KDE thing. So it's kind of nice, actually. Like, if you've ever had like the problem in Windows where you're moving your mouse around and you, for the life of you, cannot see it anywhere on the screen, what they do in KDE, at least I don't know if GNOME does it, but in KDE, if you move it back and forth a couple times, it will actually make it nice and big, so you can say like, here's your cursor. So yeah, that's not my game doing that or anything else. That's a KDE thing. So which, by the way, there's been so many times I've been in Windows where I'm like, where the hell's my cursor at? I can't find it. Where did it go? And it's like, so good to have this. It's the little things sometimes that make me happy. So let's look at the log that I generated there. Let's see what we got. All right, so it is true. Quite a bit, actually. So that's good to know. Yeah. That's good to know. So now the question becomes, why do we not move? So I'm going to get rid of this then. We know that's fine. So that means mouse move is getting set to true. So what I'll do is where I handle it here, we'll do longer debug, and I'll just say mouse moved. And I'll do delta X, delta Y, and then we'll just say delta cursor position X, delta cursor position, whoops, dot Y. All right, let's see what this, let me delete this log again. The log has been getting like super big, like 8 megs and more. And IntelliJ has been like, help me, you're trying to have me open an 8 meg file. So I'm trying to, to keep it manageable here. All right, move the mouse a little bit. Okay, let's see what it says. And the delta X and delta Y are both 0. So that would be a problem. So that would be why it's not moving the camera. So now, delta cursor position, do I actually, watch it be that I'd never actually set it. Because that would be my MO. So I'm setting it here. So let me do, well, okay, so I know for sure it's greater than 0 here. Because otherwise this wouldn't be true and we wouldn't get into here. Problem is it's not making it there, or it is making it there, but it's not it's not being read here. So So what I will do is this vector is not externalizable, serializable, clonable. Okay. All right, here's what we're going to do. I want to make sure this isn't like some kind of thread race condition where it's getting set, but then the thread that's reading it is reading it before it's getting set, that kind of thing. So let's do getter and setter on, we'll do just on delta cursor position right now. And I'm going to do synchronized on here. Like so. And so then I'm going to say set delta cursor position there. And here I'm going to say vector 2f. Delta cursor position, and then we'll just say delta y and delta x. Not sure why it's being negated, but I'm assuming that's just, well, we'll see what it looks like. I mean, I assume we're negating it because when you're moving right, you actually want it to, it would be negative instead of positive, but let's see how it looks, if this works. So what I'm going to do, oh, I should have left that logger in there. Logger, debug. What if I can just print out the whole thing here? Does this have a 2-string on it? It does. All right, cool. I can just do delta. All right, there you go. Let's see what that looks like. And it's still not really doing anything. So how are we looking here? No, delta is still 0. That's interesting. Delta is still 0. Okay, so it's not a synchronization thing per se. Delta handles. I mean, it probably should be static. Although, honestly, well, wait, is this? Oh, wait, yeah. The camera input callback is not a singleton, but I only have one instance of it that I'm passing around. But man, I don't think that's going to matter. Let's just do it for my own edification here. Just, you know, always do the stupid thing just in case the stupid thing is the answer. I don't think it is, though. Always eliminate the stupid stuff, because sometimes you're surprised. Yeah, no, it's still thoroughly 0. That's interesting. That is very interesting. And I'm almost positive it's getting set, because we're getting into here. Oh, hang on. I had a thought. So when I call handles, I pass in the delta cursor position. No, I mean, that should be... We do set it to 0 here, but... Well, maybe it's never getting unset from 0. Maybe it's previous cursor position that's screwing me up here. Maybe that's not greater than 0. We know cursor in window is true. So it might be just a matter, like, it might be a matter that this is not getting hit here. You know what? Let's just throw a breakpoint in there. Let's see if that's getting hit. Well, that's definitely getting hit. Wait, what? Oh, it's greater than or equal to 0. Oh. And it's just doing, what is it doing? It's doing, so the current cursor position minus the previous cursor position. The current cursor position is 0 and the previous is 0, so it's just saying, oh. Oh. I just noticed that. Why would we go in there? Oh, well, I guess, well, you could have the X and Y. So that's the previous cursor position, which X and Y 0, I think, is up the top left. So, okay, that makes sense. Never mind. So current cursor position is never getting set, which is that's being set here. So is this, wait a minute, is that getting set everywhere? Yeah, shouldn't that be set even when the cursor's in the window? When we enter the window? And honestly, it should be set... Well, I guess it doesn't necessarily need to be set when you're clicking a button. Well, no, yeah, no, it should be set when you're clicking a button too. Because you want to know where you're currently clicking the button at, right? Oh, but the only time I get X position and Y position of the cursor is when it moves. Okay. So then the question here is this ever getting invoked? And is it ever not 0? Let's see. Nope. Okay, so there's our problem. So we're never hitting that breakpoint, which means this is never getting set. And this comes from... Whoops, that's it. This comes from cursor position callback. Cursor position callback. Did I register the cursor position callback? Let's make sure that that happened. Where the hell was that at? That's in the engine, right? So let's get this out of here. Register input callbacks. So yes, set cursor position callback. Let's get rid of this because I don't think I need these to be that way. Just in case the default handler is somehow not working for that or whatever. Let's just do that. Just put it at the simplest point we can put it at. And did I don't think I left that breakpoint on there. Let's put that back on there again. Debug. Okay, still not getting called. Okay, so it's the cursor position callback. So it's a cursor position callback of the specified window, which is called when the cursor is moved. The callback is provided with the position in screen coordinates relative to the upper left corner of the content area of the window. This function must only be called from the main thread. I wonder if that's why they made it so that you could only move the... You could only use the mouse if you right-clicked. I wonder if the clicking makes the window have focus. Let's see something. Let's try something. I wonder if it's all of a window focus thing. It could also be like a Linux thing too, like a Wayland thing too. Like maybe Wayland is causing... Because Wayland and mouse movements and input movements, I think they've almost got it down pat, but there's still some hitches that could be there. Hey Kane, this is Java. This is Java. Okay. So yeah, let me try clicking on the window first. No. Okay, so it's not a window focus thing. So that's interesting. So is there another callback? GLFW set mouse set cursor. Oh, you dabble in Java? Yeah, it's I write in Java for the day job. I've been doing it for like 20 some odd years. So I figured when I was like, my whole goal here is to learn how to make an engine. So I thought, yes, I could have sat down and jumped back into C or C# or something like that, but I'd be fighting my lack of knowledge of the language in the same time of my lack of knowledge of how to do an engine. So I thought I could at least eliminate one of those. Like, I know Java pretty well, so I figured it would allow me to kind of focus on the real thing that I'm trying to learn and not worry so much about syntax and unfamiliar libraries and all that stuff. Pre-edit cursor rectangle. I don't know what that is. cursor position callback. That's the only, like, cursor position thing. I wonder if there's a known problem with that. Pre-edit cursor rectangle. I don't know what that is. What does this do? Sets the area of the pre-edit text cursor. This area is used to decide the position of the candidate window, the cursor position relative to one. Oh. Oh. I don't know what that does. Let me think. So let me look at their specific way that they do the cursor callback, because I think they have... I think they register it in their mouse thing, mouse input. Set cursor position callback. No, they don't do anything. They don't do anything special. Oh. Maybe I implemented the wrong invoke? I don't think so, because my invoke has these parameters. Let me see my code here. Cursor position callback I. That's the correct. Long double. What did they do? Oh yeah, they convert to float. So yeah, that's definitely a double coming in there. Oh, I wonder if somehow the window handle is not set. I put this code in just to make sure that I'm not processing mouse clicks or mouse movements when it's to some other window that's open somewhere else in the system. Just in case. I don't think it would process them anyway, but I just wanted to be completely sure about it. Let me put a breakpoint there and see if what happens. No, it's definitely not exiting early. It's just not... I don't think it's ever coming in here. Let me put one there. No, it's never... That's never getting invoked. Okay. So that's a problem. See something. Override methods. Oh, yeah. Yes. I wonder if one of these other things. These are cursor enter callbacks, right? Oh, I screwed up. I see what's happening. Because I overrode this, it's actually overriding every callback. And so everything's going to cursor enter callback, not to the callback it should be going to. That's probably what's happening. So if the function is declared returning void and its value is garbage, callback must fill the object to which this points following the same special promotion behavior. And so was it forcing me to override callback here? Let's see. unhappy. I see. Okay, so this is what. So I'm not. I see what's going on. I am not forced to implement that, but because all of the interfaces I'm implementing have the exact same method signature, the compiler is confused. And it's like, hey, you need to do something with this because I don't know which one of these to use when I come in here. Yeah, it's saying it inherits unrelated defaults for callback from types cursor enter callback and cursor position callback. I wonder if there's a way. So how would I wonder if there's a way that I can implement? No, because they would both have the same signature. So what I need to do is I need to override callback, but I need to parse these args in order to tell whether I need to go to cursor enter callback or whether to go to cursor position callback. Well, actually that might not be that bad. Well, no, it's a long args because it's a you have to call some kind of internal thing. Because I was going to say it shouldn't be that hard because the enter only has 2 parameters and the other one has 3. So if I could just get the number of parameters and I could just say, oh, if it's 3 parameters, call this other thing. Which still might be a thing, but there needs to be a. Let me see what I did. This is probably why they didn't implement all 3 of those interfaces, although kind of a big drawback. Because this kind of is, in my opinion, a lot cleaner if this would work. How does it process its args? Invoke mem get address args, get int args plus pointer size. Mem get address. I wonder if I can just get address of args. I see what they're doing. They're pulling the arguments out of memory, which are just pointers. So that's why they're saying args plus pointer size. And in this case, this is the callback for the cursor enter. So it only has the one argument. And it's just saying, does it not equal 0? Invoke native type window. Native type lane entered. This is all in their memory util class. I wonder if there's something that would tell me. How would I know how many pointers? Also, they're using Sun Misk unsafe, which is probably why I keep getting that error when I first start up. Because as it says there, unsafe is unsafe. Like, how would I know? Would there be a way? Pointer buffer. Put short realloc. Mem set. Mem slice. Trying to see if there's anything here that's like count or like pointer count or arg count or something. Mem length. That's probably not it. Allocation size. Mark offset duplicate. Okay, so I think the only way I'm going to be able to do this is to yeah, all right. I think I know the problem. So what I can do, so we know that there's a conflict between the enter callback and the position callback. So one of these has to move. Now the enter callback is pretty simple, but it is yeah, it's pretty simple. It's just a Boolean. So what I'm thinking is I can, let's think here. I'm thinking, first of all, we're going to get rid of this. And I'm betting this I don't need either, right? Because this is probably conflicting as well, and that's probably why it was forcing me to do that. Okay. Yes, it has unrelated defaults, and that is for enter callback and cursor position callback. Okay, so both of those are just conflicting. All right. So take cursor enter callback I out of here for a second. And we'll have to move this, but let me do... Because it's actually giving me a clue here, which is kind of nice. When I said like implement methods and more actions, when I say more actions, one of the clues here, is it telling me now? Yeah, one of the things it says is make it package private, and that's kind of a clue. It's not the right, it's the right clue, but it's the wrong thing. So what I could do, what I could do is I can do a inner class here. We'll say class mouse entered handler implements this guy. All right. Implement that method, the invoke, and then, which I didn't really need to do, all I really need to do is copy this down here, or copy this up here. All right. Okay, so what that does is it actually gives me access automatically to all of the variables that were declared up in this class because they're technically both in there. Still complaining about that, but I think it's okay. I think it's okay. What we're saying here. Maybe stack. It is. It isn't. Right. So the thing here now is I need that to be a thing. So I need that to be a thing. So we'll do private static mouse entered handler, and we'll do this dot entered handler is new. Fine. Let's do that. Right, and then this gets me that instance, and I need a do this. I think we'll just do a getter on entered handler. But I don't. I don't want it to be static though. That way it'll force you to do a get instance first before you do this on it, which will at least make sure that it's created. So maybe this will work. So I just have to go where I do this. I just say mouse entered handler. Is that, and down here, mouse entered handler. We'll see. We'll see if this works or not. No, it's unhappy. Oh, really? So now it's saying it gets unrelated types from... Oh, the same get call interface and get callback are shared for that one too. Frackety frack. Okay. Well, we'll just have to do the same gosh darn thing. So grab that. And we'll do this. What was that? The position handler I did? No, mouse button handler. And we'll just grab this guy. Him down here. It's a little bit, it's less clean, but it's, well, I mean, I guess that's arguable. It's arguably less cleaner, although now that they're only implementing one thing, maybe it's slightly more easy to read. Question mark. So we'll say private mouse button handler, and we'll do this button handler, new mouse button handler, kabam, which means back here we do our mouse button handler. It's mouse. Whoops. Mouse handler. Get. Oh, damn it! I forgot to make a. I forgot to make a thing. I forgot the thing. Getter for the. Where the hell is it at? Mouse button handler. There we go. There it is. I'll do get button handler. All right, now we shall give it a test. Hey, how about that? We can now move the view around. It's weird and kind of wonky, but it works. All right. And I can do it at the same time as I move around. Sweet. Okay. Yeah, it's a little weird. It's a little weird because the mouse doesn't get like recentered. But I mean, I'm not doing the work to recenter it, so it's makes sense. But yeah. Okay. You know what? Good enough for right now. Good enough for government work. Okay. We've done it. And it's actually not bad. I mean, I thought it would be a little bit more herky-jerky than it was, but it's actually not, it's not terrible. So we can roll with that now. I'm sure that'll be something that I tweak a hell of a lot in the future anyway, once we get more of an engine underneath us. Anyway, and actually, they were doing it by mouse sensitivity, right? So I probably should look to see what numbers they were getting, because it would have been, well, it would have been like probably 16, 17. So 17 times 0.1, so 10% of 17, which would have been 1.7 instead of 0.17. But we'll have to figure that out at some point, because you're definitely going to want the mouse to have a different sensitivity than the keyboard and all that stuff. That's something to tackle at another time. All right, so I would say personally, chapter 9 is done. So let us commit our stuff. And I'll put input timer in there for now, even though we're not using it. Cool, that's committed. All right. Now then, on to chapter 10, which I was taking a quick peek at, and they're just changing over to the Vulkan memory allocator, which it looks to me like I did a little diff between chapter 9 and chapter 10 in the book code. And it looks to me like there's not a whole lot of change based on what I'm seeing. This is just, I put that logger debug in so we can actually ignore the main method here. There's no change there. So there's materials, there's models, cache, has a few changes here and there. Attachment, image. We have a whole new class called BEM alloc, so this will take, I mean, that's not even a very big class, that's not bad. Texture has a few changes. The VK buffer has probably the most changes, right? Because it's doing different allocations. They've added a cleanup for the mem alloc thing and a crate for it, so we'll have to do that. And then some of the utilities, some of the flags change that we use in the utility. So it's actually not terrible. Like, there's nothing else besides that. So I think we can probably knock this out relatively quickly, fingers crossed. Unless I've made like a huge change somewhere that throws a wrench and everything. But materials cache and things. So let's get this the lower screen. I'm going to close all the tabs here so we start fresh. Close all tabs. We'll make this the top frame. I'm going to start with the materials cache. We want chapter 10's materials cache. Down here. All right. Cool. Cool, cool, cool. Okay. All right, so two things. One, I want to sit down again. So I've been standing this whole time. Two, I need a little bio break. So I'm going to do both of those things, and I will be right back in a few minutes, friends. Enjoy the music. Okay, I'm back and sitting again. I can turn the webcam back on. Excuse me. Oh man, good stuff. I gotta maybe tonight after I finish the stream, I need to buy a humidifier. It's time. It's time to get a humidifier in here because the air is so dry that my hands are just like 2 pieces of raw meat right now. Like I gotta wash my hands and it's just dried blood and it stings like hell and it's like this is something has to give here. Oh man. Anyway. Cool. So let's see if we can get through all of chapter 10. So what do we got here? We got import static, which I hate, but okay. VMA. What's importing from? Until there was some other. Do I have to bring in a file change, don't I? No, I guess not. Okay, never mind. Never mind. I am wrong. So what did they change here? Load materials. The source buffer and the materials buffer. Okay. So load materials, source buffer. All right, source buffer is welcome buffer and buffer usage transfer source bits, and then what is it? It's VMA memory usage auto. Buffer size. Oh, VK buffer is taking a new parameter. Oh, let's do, okay, so we gotta do VK buffer first. VMA usage, I see, okay. So let's go, open buffer, so we got buffer usage and VMA usage. All right, so let's Alt Shift R, we'll say buffer usage, and then int VMA usage there. And let's see, so map to memory is null. Let's memory tilde null. Stack push. Type default, requested size, buffer usage, sharing mode exclusive. Okay. All right, and then they've got a VMA doc info, VMA allocation create info. Where do these VMA flags and stuff come from? Oh, they've got VMA usage, VMA flags, and required flags. Is that mask that I have on here? No, they don't even use mask anymore. It's just required flags. Mask. Oh, it went down into there. Okay. So that's gone. So it's VMA flags. It's required flags. Okay. So where does VMA allocation create info come from? LWJGL util VMA. So I guess I don't have the LWJGL VMA. What was it? Util VMA. They do have it in here. Why doesn't it show up as a difference? I don't know. But we'll grab that and that in my palm here. So I'll just put it after shader C here. Do that. And then we'll do Maven, sync project. Maven, download sources and documentation. There we go. Alright, so now this should be visible. Import class. There we go. Alright. Now it knows it. Good. So then instead of the long buffer, we have a pointer buffer. Where's that going? Okay. So this is pointer buffer. Equals stack or pointer size of 1. And then long buffer stack malloc long 1. And we're VK, so this is VMA create buffer. Where's that come from? Okay, so instead of VK13, it's VMA create buffer. Create buffer. Allocator. Allocator. Buffer crate info. VMA, alloc info. Long buff. Alloc buff. And then null. Now to create buffer. Okay. And then buffer is long buffer get 0. I have an allocation now. So we'll say have it long VMA allocation and that gets this dot VMA allocation gets buff gets 0 and memory alloc pointer buffer oh I see pointer buffer. What was I saying pointer buffer to before? Oh, it was just getting set maybe. Oh, it's down here. Okay, yeah. So this dot pointer buffer equals memory till and alloc pointer 1, and then there's nothing else here. Looks like. Let's see. Oh. Am I doing... Oh, I'm doing Vulkan buffer, that's why I'm like, what? Why is that not looking right? VK buffer. Yeah, they've gotten rid of a bunch of stuff. Nice. Yeah, so they got, okay. Which actually kind of simplifies it a little bit. I like the lesser code. So what I need to bring in though is get mem-alloc is what? Memory allocation. Okay, the memory allocation util into VK buffer. So we'll have to do so we'll have to do that. Let's bring that in. And say that VMA allocator. And then in cleanup, free up the pointer buffer. we call unmap. And then it's VMA destroy buffer. Need that allocator again. I call it get VMA allocator. Alright. And then buffer and then allocation. So buffer and then VMA allocation. Okay. Go. And we have flush, which has no usages, but I guess I'll put it in there anyway. And this is application util, VMA flush allocation util get VMA allocator, VMA allocation 0, VK whole size, is that VK 13? Yeah, okay. VK 13, VK whole size. Alright, and buffer, get requested size, map to memory. So then this is VMA map memory. I need this. Calling it, yeah. That allocator, VMA allocation, pointer buffer, and pointer buffer get returned map memory. All right, and then unmap. Map memory is not null. VMA unmapped memory. Damn it, this thing. So allocation util get VMA allocator. VMA allocation. That memory is null. Alright, good. So obviously we should probably jump over to the new class here. Memory allocation util. And I'm just going to put this under utils. In Vulkan engine. So go here and we'll say new Java class memory allocation util. All right. Logger. Yep. Good stuff. Good stuff. And private final long allocation, I guess. Public allocation util instance, physical device, and device. This is the render instance, right? Yeah, it is. And logical device gives me access to the physical device, so I don't need to pass both, which is nice. Alright, try stack equals memory stack dot stack push. Pointer buffer. Stack. Pointer 1. VMA Vulkan functions. Okay, that's so VMA Vulkan functions. Okay. Colic deck. Wait, what am I doing? What am I doing? Set instance, get VK instance, device, get device. Alright, and then var info equals VMA allocator info allocator create info colic stack instance is get VK instance Vulkan API version K13 VK API version 1.3 device is device.get device physical device is device get physical device, get physical device. There we go. The Vulkan functions is VMA Vulkan functions. All right, and then Vulkan utils fail if needed. VMA creates allocator info alloc buff failed to create VMA allocator. All right, and then this dot, this should be VMA allocator. Equals alloc buffer get 0. And then we got public void cleanup. That's just VMA destroy allocator. Got it. Let's what did I mess up here? Oh, I'm inside the other method there. That's what's going on. I was gonna say I thought that looked a little bit weird. Whoops. Got that. Public long get VMA allocator. Okay, so that should solve most of those errors that we're getting over here, right? It looks like it. Looks like it has indeed. And we need device and application util. No. Good. Which means we jump all the way back to material cache now. Because I need to pass in, so load materials. Oh, yeah, because load materials is doing Vulkan buffer, so I need the allocation util. And now this is, so Vulkan buffer takes what now? Device, memory allocation util, so this is allocation util, right? And then buffer size. buffer usage is transfer source bit, and everything else is different. So VMA usage would be, now is this coming from the same thing? It's probably coming from VMA, right? Yeah, okay, so this would be VMA memory usage auto, VMA allocation create host access sequential write bits, and then VK13 VK memory property host visible bits. That's for the source buffer. And then the materials buffer. So we pass allocation util back in there. We have buffer size, destination bits, and this one, the next line here. It's destination bit and storage buffer bits, and then it's VMA VMA memory usage auto 0. Oops, 0 0. Okay. Now you have the transfer buffer. For materials buffer, and then we have material data buffer, memory till byte memory. So this would be mapped memory. Where's that? Oh, source buffer. Oh, so it is source buffer map. Yeah, it's just device and cache util source buffer gets requested size. Okay. I'll set 0. So material map. Load. So did that change? Where am I at now? Materials cache. Now it looks like everything else is the same. It just changed those flags. Although I do have to pass an additional thing in here, but that should be fine. Okay. Should make sure down here everything's fine down here. Yeah, everything's good there. Alright, so I think material cache is done. So models cache. Looks like just a very similar thing with the flags because the buffers are different now. Okay. so that's, what is that? Models cache. Okay, and oh, it's in the crate indice buffers. Okay, so that's actually down a little bit further here. Transfer command? No. I forget where I put it. Where did I put that at? It's in. I do need to fix this anyway. So source buffer is device and the one where the other that had to be fixed. That's not where I wanted to be. Create index buffers. And add mesh here. Yeah, there we go. Maybe. Yeah, mesh data, blah, 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 source, destination. Yeah, here we go. So this has to now take memory allocation util. Device, and then allocation util. Let me just get that first. Buffer size. Then transfer source bits. And the rest are different here. So VMA, memory usage auto. VMA, allocation crate hosts, access sequential write bits. VK13, VK memory, property hosts, visible bits. Okay. Destination, buffer size, transfer destination bit, usage index buffer bits. Buffer bits. And then it's VMA, memory usage auto, 0, 0. I think that's all that changed there. I have to fix all of these. Yeah, oh yeah, the create vertex buffers and stuff. So models cache. I'm surprised it doesn't. Oh, it is in there. Create vertex buffers and create index buffers. Got it. Okay. So we got to do allocation util. And it's transfer source bits. These are basically the same, it looks like. So VMA, memory usage auto, VMA, allocation, create host access, sequential write bits, and VK13 VK, memory property host, visible bits. This one, allocation util, usage transfer destination bit, vertex buffer bit, and then VMA, memory usage auto, 0, 0. So allocation util in there. And into there. Still have 2 errors. Yeah, because add mesh now has to take the allocation util, pass that down here. Like so, I forgot. Comma there. There's that. That means this also has to take it. There you go. All right. Good. There's going to be a lot of other breakages, but I assume we'll come across those as we come across them. It'll be easy enough to just try to build and then have it just break and then show me all the places that broke. All right, so it's models cache. In here, we do some changes to attachment. Looks like just the constructor there. Image data, so image data. Oh, he's added a new thing, new Vulkan image. What's that? Mem usage, is that what he added? Width, height. Usage is usage or VK sample image, but that's the same. Format. Yeah, you just added the mem usage property. So that is what? An int. Okay. Put that up here. Private final int memory usage. Okay. So then back here. So I just have to say VMA allocation create dedicated memory bits. And that's the only thing? That's the only thing there. Image now has to take that into account, obviously. So private funnel long allocation. Yeah, okay. So image. So allocation is that. So just do, let's see, private final long VMA allocator. And so after image create info, telling optimal usage. Okay. So then we have a var VMA allocate info VMA allocation create info calloc one stack. Oops, I keep doing that. Get 0 usage is VMA memory usage auto flags is usage to stop memory usage. Already 1.0f. Alright, and then we need a pointer buffer application buffer is stack pointer 1 long buffer, and then we do, instead of bk create image, in VMA create image, and that is, I need the allocator in here. So I do, where am I at? Right, so down here we need VMA allocator, image create info, just info. Create info, buffer, allocation buffer, No. Alright, and then say this.vma allocator equals allocation buffer get 0. And that's set. So then I don't need any of that then, right? Image. Yeah, get memory requirements, select memory size and usage, allocate memory, bind memory, that's all. It all goes away. This just ends there. So I guess I don't need a memory handle anymore then, right? Doesn't look like they have that there. I think I put that there. Well, oh yeah, they had VK memory. They got rid of VK memory. Yep. Never mind. So whoops, that's the wrong one. I'm looking at that one. I should be looking here. Yep, my handle goes away. Alright, so then in cleanup it's we need the device and we need allocation util. And this is just VMA destroy image. Allocation util VMA allocator ID and then VMA allocator. Alright, VK image is that basically is ID. VK image is LP that yeah. ID and that. Get format, get MIP levels, get ID. And then that's it. Okay. Okay. So we've done this class already. Yeah, this class is done. So texture, we have to just change the create staging buffer. Flags, okay. Pull that up here, texture, and we're looking for create staging buffer. And oops, bring that down here. Welcome texture, create staging buffer. Yeah, I'm gonna need already. I need memory allocation util. So I got welcome buffer, allocation util, size, usage, transfer source bits, and then all of this changes to VMA, memory usage auto, VMA, allocation create host access sequential write bit, and VK13 VK memory property host visible bit. And then this is device and allocation util. And set staging buffer map byte buffer, flip, and then unmap. Okay. And then the cleanup. Did they change anything in there? Cleanup staging buffer. No, okay, but I need to change stuff because I'm not passing that whole thing in. So we do location util. Pass that here now. Go. And then I need that here. So I can pass it to here. There we go. One more problem. Vulkan image. Oh. Texture Vulkan image. Oh, this has to take a location util. Yep. What's wrong now? Device allocation util with height usage. Oh, there's a memory usage now. MIP levels, memory usage. I'm surprised I don't have that up here. Oh, I guess they default it to something. What do they default? Usage to... They default it to 0. Alright. So then there's 0 then. Okay. What else? So that's texture. BK buffer. I've already made these changes. Then we gotta spin up the memory alloc thing. So that would be so okay, context after the descriptor allocator. New descriptor allocator. So here, I'll just put it here then. So we'll say memory allocator now. So private final memory allocation util. Allocation util. This that equals new. Allocation util. Instance device. Go. And then let's add it to the cleanup. Clean up the descriptor allocator somewhere here. Here it is. So right above the descriptor allocator, we do allocation util cleanup. Good stuff. And they have a getter for it. I need to pass it where it is needed. So there, here, here. Good. Good. And then we have to change a utility, right? Create host visible buffer. Both of the create host visible buffer classes. Okay. That should be straightforward. Great. I'm also going to need it in the copy matrix to buffer. So let's do issue till there. And host visible buffer, I'm going to get in here. Pass it here, and then size, usage, host visible. Why is that still set? No, this is wrong. That's chapter 9. Try that again. VK utils. Chapter 10. Yeah, here we go. Buffer size. So we have what? Buffer size, usage, ID. Okay, so same parameters there. So size, usage, and then get rid of this. And we say VMA, memory usage auto. Oh, auto prefer device. Most screwed that up. VMA allocation, create hosts, access sequential write bit, VK13, VK memory property host visible bits. Oh, right. So we're rocking there. And then just gotta do the same thing down here. Pretty much. Device, allocation util, size, usage, and then this is auto prefer device. Auto prefer device, VMA allocation, create host sequential write bits, VK13, memory property host visible bits. There. All right. I think that's all they've changed. I'm gonna have, I know there's some breakages here that I'm gonna have to do, so let's do a build and see what breaks. There we go. Walk-in mesh. Oh yeah, okay, that's gonna need a thing now. So I'm gonna do allocation util. Oh wait, no. Did that wrong. What am I doing? That's wrong. Down here. Do it down here where it's needed, not where it's not needed. Allocation tool. There we go. Go, and let's try build again. Okay, and then this takes, so cleanup's going to have to take location till there. Add texture needs it. Go. And there, that's broken a lot of other things. As I would expect it to. And here. Till that. And for this. Okay. So the renderer needs. Oh wait, does this have allocation until already? Yes, it does. Where's the other? Here it is. I just need that here. And this needs it as well. Place down here, yes. I'll break a couple places. Yep. Material cache. Okay, I just need to use that. It's already passed in. More stuff here. Scene renderer, 19 in this one. Okay, so where are we? We begin here. Where's the first one? Seven arguments. Allocation util. Did I don't have one in here? Okay, so put that at the end there. And same here. Allocation util. Device. Oops, that's what I'll do. There we go. And need allocation util here. Need it here as well. Okay, that's going to break a bunch of things. There we go. So this is allocation utils at the end there. That one. This now takes memory allocation util. And this takes it at the end. And at the beginning. Okay. So far so good. Alright. Another breakage here with Vulkan image. Yeah, that makes sense. Attachment has to take it. And then clean up. Ah, damn it. Go. And when we call attachment, we need to pass that in now. Wait, don't I have access to... No, I don't. Okay. I fix that? What's the... Oh, up here. There we go. And let's see what else breaks. Oh, nothing. Okay. Okay. And I'm guessing there's not much of a change, so we should still see the scene that we had before, but perhaps it'll be a little bit faster? I don't know. Nope. Crash. We have to locate library lib LWJGL VMA SO. Was there something else I needed to bring in? Because there's natives here. I wonder if there's a native. There probably is for the VMA, right? I bet there is. So let's do this. And bring that in. And we'll say classifier. Natives. And I'll do Maven sync. And just for sake of argument, we'll do download sources and documentation. All right, let's see if it works now. Indeed it does. Nice. Okay, we're still right where we were. So that's good. Keyboard's kind of working and kind of not, but you know, it's just like a little bit of a transition problem there. When you go from like one side to the other. Yeah, sometimes like I hold it down, it doesn't do it. So I have some problems still there, but that's good. All right, Outlaw. You have a good night, and yeah, talk to you tomorrow. Okay, cool. So that is that's that entire chapter done. We finished chapter 10 in like lickety split time here. So I am happy with that. Motoring right along. So chapter 10 finished. Cool. Commit and push. Commit anyway and push. There we go. Alright. So what is the, so now if I compare files, we do chapter, oh, I already have chapter 10, this was chapter 9 to chapter 10. Yeah, okay. I have chapter 10 to chapter 11 here. Yeah, they're doing, this is post-processing. So the next chapter does all kinds of post-processing, so FXAA and all that stuff. So I'm really interested to see how this all comes together, because there's a lot of shader changes here. So that's good. They're also adding, a flag for FXAA. In the render, it looks like we have a whole new class called post render and a swap chain render. So we're doing all kinds of new things there. They have a whole folder now for this post render, which is a pretty beefy class, it looks like. Spec constants. Let's see what that's all about. Scene renders got a lot of changes. There's a whole new swap chain render, which is a big beefy class as well. And we have an empty vertex buffer structure. That's a thing. Image has width and height now. They moved width and height into image. That's pretty funny because they had it in image data. Oh, it's still in image data, but now it's in here, which the funny thing about that is since I eliminated the image data, I already have width and height in here. So it's like pipeline looks like they're doing there's new shader modules now for post-processing you have to take into account. So there's that. Shader module has a little bit of changes, which is pretty cool. And yeah, just specialization info, surface. A few changes to image format. UK utils, they added a vector 2 size. That's pretty simple and straightforward. And the engine property. So a lot of this is just kind of new classes. There's obviously a, what was the one? It was scene render. Scene render has a ton of changes, but that's kind of where the rubber meets the road anyway. Kind of, sort of. So that makes sense. But we could probably, most likely, be better to leave that to the end. And then just do all the other things around it. Probably like the posts and the swap chain and all of this stuff. Because it looks like I can get probably through this one. Everything in this package, the VK package, I could probably get through pretty quickly here. The other things are just kind of lengthy and just their size. Posts, constants, render. Just has a few parameter changes, it looks like, and another new class. Yeah, alright. This doesn't look too daunting. I think probably the most daunting thing of this is the shader changes, but obviously learning to do shaders is a whole other ball of wax, and this is actually not that bad. I mean, I'm basically going to be just copying more or less what's here, which they themselves copied from somewhere else. So, because there's the attribution for it. So yeah, I'm gonna kind of just roll with that. But yeah, cool. All right, but that will be that'll be for another time, friends. Because I think I'm happy that with the progress that we've made, I think we're doing pretty good here, all things considered. Couple more chapters, obviously, to go through. I mean, we're now on technically chapter 11. We'll be starting that, right? Which is over yonder here. So post-processing. So we're doing chapter 11, and then I was looking ahead at some of the other ones. I think 21's not finished. That's ray tracing. 20 is multi-thread, which is, I think, the last big thing. And I think the appendix appendix 1 is applicable to us troubleshooting device loss errors. I probably want to incorporate some of that as well. But yeah, we've come quite a distance here. So 11's post-processing, 12 is go into some GUI stuff, and I'll probably just use in GUI for now, and then see if that's the library I want to go with, or if I want to go with something different, if there is something different. Chapter 13 is sound with OpenAL stuff, so that'll be interesting to kind of dig into for the first time. First time that I've ever really worked with it. I'm familiar with OpenAL because it was something I briefly kind of took a look at back in college when I was doing graphic stuff and looking at OpenGL and C, and I did I think OpenAL was just really, really young at that point, it had just come out or something. But yeah, that'll be interesting. 14 is, so 14 and 15 are this deferred rendering, which these are, from what I can tell, fairly beefy changes, because they've broken it into 2 chapters. So there's this one where you're rendering the geometry deferred, and basically this means you're not utilizing the CPU as much, you're making the GPU do more work. I believe is ultimately the goal there. And deferred rendering 2 is I'm particularly interested in, because that starts to bring in some PBR stuff, physicality based rendering, which the model that I was loading up in OpenGL, the little spaceship model, one of the things of that was that had some PBR stuff in it that I was not handling for obvious reasons. It's pretty complex. So it'd be interesting to get that into Vulkan and then load up that model and see what it looks like. Be really, really cool to see that. Because I think it had the engine glow, I believe, was like PBR or something on that ship. And then 16 is shadows, cascade shadows and stuff. So these are all really, really important things, and I'm really excited to get into them. Then we get into animations with skeletal animations and stuff. Obviously something very important, but I have a feeling, just kind of briefly scanning over this this chapter. I mean, it's a beefy chapter here, but I get the feeling that this probably only scratches the surface of animations. So we'll see how that goes. And 18 is what? Buffer device address, virtual addresses and shaders instead of using descriptor sets. So, I mean, that's obviously a nice little thing. This is probably I would imagine this is mostly shader changes and probably not a whole lot of things that have to happen in the code itself. So that'll be good. And then indirect drawing. So I'm sorry. Indirect drawing is where we start to go from being CPU bound to performing a lot of stuff such as calling in the GPU. So this is what I was really referring to. So that's like chapter 19. That's way towards the end. 20 is just the multi-thread, as I said, which is also very important. And then after that, we're kind of thrown into the wild after that. We'll have the basics of an engine, and then I'll want to go through, clean up a whole bunch of stuff, refactor a whole bunch of stuff so that I can better understand what's going on. Probably get rid of all the OpenGL stuff that's in there. Move some things around, rename some things. And then I think 21, they were talking about ray tracing, but I think the next thing that I would do, rather than necessarily ray tracing, is I'd probably start to look into physics modeling and potentially PhysX, but I maybe would want to support that, but I also probably would want to support stuff for AMD as well, whatever the AMD equivalent of it is. So potentially some of this, some of that, do some physics calculations myself too a little bit. I don't know. We'll see. That's going to be the real hardcore math stuff, and that's going to be a spicy meatball right there. A very spicy meatball. But yeah, that kind of gives you like an idea of what's coming up there with that stuff. So yeah, that'll do it then for me for tonight, my friends. Thank you so much, everyone, for watching. I don't know what I'm doing tomorrow night. I might be playing a game. I might, if the mood catches me, I might be doing more coding. I don't know. I'm kind of hoping to do the coding in the afternoon tomorrow. I didn't really get a whole lot of time to do any coding today, because I had to do a lot of running around, off-camera coding. So that's kind of why I felt like, hey, I just want to sit down and do it in a stream. So I might probably be doing a game tomorrow night. Thursday obviously is no stream because Christmas, and I will be at family get-togethers for that. Friday nights will likely be coding as usual, and same with Saturday probably, although because I've done this extra coding stream, maybe it'll be a game thrown in there somewhere. We'll see. I'm going to kind of keep it a little bit fluid this week. And then no stream on Sunday because I have another family gathering to do then. So that's kind of the schedule right now, as I know it, my friends. If you happen to run across this on the YouTubes, and you have a like and or a subscribe that you can spare and maybe toss my way, that would be really swell and awesome. It helps out tremendously, and I appreciate it greatly. Otherwise, thank you so much for watching, everybody. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. I hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
Oopsie.